Hello, I'm Kimseungmin, and this is Physics 2211 Lab 4, Oscillations. Introduction. The goals of this experiment is to compare the predicted motion with the observed motion of an oscillating mass attached to a spring and plot the energy changes computed in the model. Findings of my experiment is that the predicted motion and observed motion are similar, but there are minor discrepancies in the y-axis motion. And also the change in the total energy is equal to 0. Key concepts of this experiment includes Newton's second law, momentum principle, F net equals delta momentum divided by delta time, velocity update formula, and position update formula. Net force is gravity plus the spring force. F gravity equals negative mg, and F spring equals the spring force formula. Energy principle, or the law of conservation of energy. Energy is not created nor destroyed, but changes form. Delta E system equals work by the surroundings done to the system plus Q. This is the tracker video. Quick analysis of the tracker video. The FPS is 10.53 FPS, which is 0.095 second per frame, and the mass is 0.402 kilograms. The start time is 0 second, and the object's initial position is as written here. And these values are reflected in the code as so. The ball's mass, ball's position, and delta t. This is how, the gravitational constant is set to 9.8, and the spring constant and the relaxed length of spring is edited according to the pre-lecture video. Distance from the relaxed length of spring, energies involved, and net force, velocity update, position update formula, and finally change in energies are reflected in the code as well. This is the result video. These are the quick snapshot of the graphs of the results. First of all, let's look at the change in energy along time graph, which is the first one right here. All three graphs oscillate except for the total change in energy, which is in orange. The change in gravitational potential energy, which is in red, has opposite sign with the change in spring potential energy in green. As you can see, when the green increases, the red decreases. When the red increases, the green decreases. The change in kinetic energy, which is in blue, has smaller magnitude compared to potential energies. The blue graph right here has smaller magnitude compared to these two. Let's look at the position versus time graphs, which is these two. It accurately reflects the movement on x-axis, as you can see right here. But in the y-axis, the model doesn't reflect the movement as accurately as in the x-axis. For your model system, is the energy principle satisfied? Yes, it is satisfied. As you can see, the total change in energy always equal to 0 because the sum of these three energies, potential energies and the kinetic energy, is equal to 0. And we can also make estimates of oscillation periods by checking the time between the tips of these graphs and dividing it by, and taking the average of those values. And I calculated that the average oscillation period for x-axis is 1.65 seconds, and for y it's 1.49 seconds. This difference is likely caused by the drag force due to air resistance and by the tracking error in the tracker system.